there are a lot of people, but I'll try to. You put all the pieces around. One piece is here, one piece is there. That's the computer that is controlling the setup. So the setup is based on a webcam, standard one. That's the arm that we built here with standard servos. And we built the base, so this part is customized. While these other parts here, you can buy them from what's the name? Links Motion. That's the card that interfaces the servos with the computer via serial port. And all the software, as I mentioned, is built in Java. So there are in the program there are the controller of the acquisition of the image from the camera, and the controller that sends commands to the servos, and also a piece of code that generates the stimuli for the system. Okay? So there are all the three parts are synchronized. So now we are going to see the first demo, that is the most complex one, and it shows the reinforcement learning part of the system. So this is the system that has been trained during the three phases that I mentioned before. And now it's the fourth phase, where it's trying to achieve one of these three dots here. And the goal, as you remember, is to reach the dot that has the same color of the central dot. And if you remember from my presentation from before, the system has acquired, during learning, a bias to reach objects that he sees. So it tries to see anything that is in the screen, for example. If you put something else, it might want to go there. I never tried this, let's see. Okay. So it has a bias to reach things. Okay? And this helps the reinforcement learning part, that is the fourth part, because it tries to reach objects and eventually gets rewarded. For example, in this case, would have get rewarded if he reached the red one, while he received the central one. Okay, now he got rewarded, I guess. Did it? Yes. Okay, from the screen here, we can see the points that it reaches, and if they are green, it means that it got rewarded. So the reinforcement is delivered through via software. It's not the check on where the arms goes. But there is a correspondence between what the system is doing there and what the arm is doing here. So in the future, we will deliver the reinforcement when the arm reaches exactly the ball. For now, the reinforcement is simulated here.
And the actions, so each action is go from here to one of the dots. It could be any, also your this dot, and this limits the space of possible actions, and one of those gets a reward.
Yes, exactly.
Okay.
Let's see how everything works, and this part will be more clear. So this is the image that the system acquires, so it's quite dirty. You can see. The first thing we do is we subtract the initial image without anything, because this image is a disaster. If you could see, this light is very, very strong. And so we acquire the first image and we subtract it from what the system sees after that. This is what you get, so only the three balls. And we cover the arm with black tape, so it's invisible to the system. Then here we have the reduced image. So this is 40 by 30, while this one is 230 by 320. Okay, so this is the reduced image, and also it's an average of groups of pixels, so there is less noise. And here there is a Sobel filter that detects the contrast. So you can see that here the system detects the edges of the balls. Then what happens is that so you have this bit of information here, the system gets that, and here you have the votes. So the system has this bias to reach objects in the environment. You can see here this neural network implements the votes to reach any one of the objects in the environment. For example, this one, and this one. This one is already in the space of the postures. Okay? And so there are these votes that go to a dynamical neural network, and that's the one. And here there is a winner-take competition between clusters of units. So for example, you can see here the central pattern one, or the one on the corner one. So as soon as the activation of the most activated unit reaches a certain threshold, the system goes in the corresponding posture. Okay, so that's the idea. So we are there. And then when there is a cluster of units that wins, that reaches the threshold, the weights that go from there to the system are activated, so there is an encoding of the specific posture that has been learned in the previous phases, and the posture is actually executed. So the system now is learning by reinforcement learning, and when everything works, it takes, where is the mouse? On the other side? Yes. Oh, it is. It takes 100 steps to learn the four patterns. So it's going. If I clean the image, you see how it goes. You can actually see it right there. So, for example, wrong answer, right answer, wrong, right. So we are about 50% of the times. If you wait for some times, and if the camera is very well calibrated with the base, then it reaches the maximum performance.